Guys. All right, guys. So the plan here is to just knock out questions 9 and 10 in this video, and then we'll talk about the last idea, which is the rational zero test. And maybe we'll even start questions 11 through 15. Maybe just do like one of those, and then the last video can do the rest. Okay, but starting first of all with questions 9 and 10. So let's find the value of k for which x plus 3 is a factor. Okay. So x plus 3. I'm looking at x minus c, right? In x plus 3, that means this is x minus negative 3. So your c is negative 3 here, right? So when you have a factor like x plus 3, c is negative 3. So that means what I'm going to do is I'm going to run my synthetic division here. Okay. This is negative 3. That goes in the box, right? And I'm going to write my coefficients. Coefficients are 1, 3, 1, and the last one is k. K is the coefficient. Okay, got my line. I'm going to run the algorithm. Let's switch colors here. 1 comes down. 1 times negative 3 is negative 3. Add them together, I get 0. 0 times negative 3 is 0. Bring the 1 down. 1 plus 0 is 1, right? 1 times negative 3 is negative 3. Now, I want this guy to be 0, right? So it's actually a super easy fix. What should k be so that k plus negative 3 is equal to 0? And the answer is just the opposite of this guy, right? So if k is equal to 3, this will be 0. So k is 3. Easy. That was number 9 I just did. I have not been consistent with labeling once again. Sorry, guys. Okay, let's do 10. Number 10. Same procedure. And let's use blue this time. Number 10. So first of all, same factor. I'm still dealing with x plus 3. That means c is still negative 3. It goes in the box. Coefficients 1, negative 1, positive 1, negative 1, and then k. My line goes there. Bring the 1 down. 1 times negative 3 is negative 3. Negative 3 plus negative 1 is negative 4. Negative 4 times negative 3 is positive 12. 1 plus 12 is 13. 13 times negative 3 is negative 39. Oh, this is looking pretty ugly, huh? Pretty ugly. Negative 39. Negative 39 plus negative 1 is negative 40. And then negative 40 times negative 3 is positive 120. Now, when I'm doing this synthetic division, if it divides perfectly, the remainder should be 0. So k to get 0, what plus 120 is 0? Negative 120. So then k must be negative 120. There it is. It's the answer. Oh, that was easy. No problem. Okay, in this video, because I was so short, we're gonna get started on the last topic here, guys. Let me talk about the theory of the last topic. This is the rational zero test. Okay, great. And then maybe we'll do one question and wrap up this video. The rational zero test, I'm sorry for the inconsistency here. Actually, this is consistent with the topic at the top, zeros, and then here, rational zero test, which is consistent with the title. So, I think it's the rational zero test. But you can check your book for which tense it is. I wouldn't fault you either way, because we're finding rational zeros. Okay, the rational zero test says, if you have a polynomial of the typical form, right? This is the standard form, right? Here's the biggest degree and your coefficient for it. Here's your constant term. Now, it says, if you have a polynomial of that form, then if P over Q is a rational zero, or if it is, sorry, then it must be the case that P divides the constant term and Q divides the n term. Okay, yeah, so that gives you a kind of shortish, depending on the numbers, list of possible factors of the polynomial, and it's a good starting point. Now, what I want to do is give you an example of this. Let me look at the question, see if we have a good example here. Yeah, okay, so decent example here. I'm going to just actually copy and paste this question here, so I can just explain this to you real quick. So what is all that mumbo jumbo saying here? It's saying, okay, when you look at this first coefficient for the biggest term here, that would be 1, right? There's like a missing 1 here. This guy, that goes on the bottom. That's the Q term. Or, Q divides. It's not the Q term, but it's Q divides. Oh, I can't spell divide. Divides. It looks so weird. Okay, because my u looks like v. Q divides this term, okay? And then P divides that term. That's all the theorem is saying. P divides this term. And then any rational zero of this polynomial is going to look like P over Q. So what are the possibilities? Okay, so what things divide 4? Let's start with P. So P could be, well, you always get plus or minus 1. And you always get plus or minus because for something divided, it could be positive or it could be negative. So you get plus or minus for each number. P could be plus or minus 1 because 1 always divides everything. It could be plus or minus 2 because 2 divides 4, or it could be plus or minus 4. You know, what about Q? It's got to divide 1. So Q could be only plus or minus 1. That's it. Those are the only options, right? Okay, so I'm looking at different possibilities where P is one of these numbers, Q is that number. So what fractions could I make? Here are some possibilities. Or I should say, could be. So P could be 1 on the top, and then Q is either 1 or negative 1. So it's 1 plus or minus, or I read it, plus or minus 1 over 1. That's a possibility. P could be 2 plus or minus, and Q will be 1. Or plus or minus 4 over 1. In this case, because Q can only divide 1, that makes things simple, right? It means there's no fraction values. So 1 over 1, of course, is just plus or minus 1. So I don't need to write it as a fraction. 2 over 1 is really just plus or minus 2. So I don't need to write that as a fraction. 4 over 1, of course, is just plus or minus 4. So that means these 6 numbers, 1, negative 1, 2, negative 2, 4, negative 2, those are the only possible roots that are rational numbers for that polynomial. So now that I've gotten that far, let's just finish out that question. Okay, so let me see what I got here. Let me just bring this. Oh, okay, actually, what is the question? It says to state the possible rational roots. That's what I just did, right? Use synthetic division to find all the maybe the quadratic equation to find the zeros. Factor completely, sketch a graph. Okay, I gotta do all those things. You know what? Let me do it like this, guys. Let me just get this whole thing, and we'll do our usual thing. Okay, we'll take these things and do them one by one. So 11 part A finished, right? Well, let me just write it. Okay, let me just write it again. Part A could be plus or minus 1, plus or minus 2, or plus or minus 4. So now, part B, using synthetic division and maybe the quadratic equation, if applicable. What I'm going to do is, once I get this down to a quadratic, then I'm going to apply the quadratic formula. So it's going to take me one extra step, right? So let's check 1. 1 is always the easiest thing to check, right? And what are my things? 1, negative 1, negative 4, 4. The 1 comes down. 1 times 1 is 1. Add together, get 0. 0 times that is 0. Add together, negative 4. Negative 4 times 1 is negative 4. And at 0, yes, I got lucky. So 1 is a factor, right? And not only is 1 a factor, but I have the result of dividing right there. So here's the remainder over there, right? This represents the resultant quotient. That's x squared plus 0x minus 4. Turns out I wasn't so lucky because there's 2 other possibilities. I had a 50-50 chance, actually, because 2 and negative 2 are factors. Okay, here, this is such an easy thing to factor. So far what I have is I have x cubed minus x squared minus 4x plus 4 is equal to that first divisor, x minus 1. How did I get x minus 1? Well, I just checked 1 and it worked because I got a 0 remainder, so x minus 1 was a factor. And then the resulting quotient, right, x squared minus 4. So far I have that. Now the last part to factor is really easy. I don't need to use the quadratic formula because this guy is really easy to factor. It's just a difference of squares, I think. Right? X squared is a square, 4 is a square. So this is x minus 1. This is x plus 2, x minus 2. So there, it's factored completely. Yeah. Use synthetic division, quadratic equation, find the zeros. Okay. Factored, we did that. Okay. And then now sketch the graph. All right. So here's the graph. Okay, remember my process for graphing? I already have the x-intercepts, right? The zeros. Zeros are at 1, 2, and negative 2. So So here's 1, 2, and negative 2. Okay. Now I'm going to look at end behavior. To the left, as if x is a really big negative number, what happens? So all I have to care about is that x cubed term. Big negative number, it's going to look like it's going to go to negative infinity. So that means it's going to approach from the bottom, yeah? Now notice all these are degree 1 factors, or the roots of, what do you call multiplicity 1, I mean? Which means when I graph the thing, it's going to pass through each time. It's not going to kiss any of those. It's going to go straight through. Remember what we did with graphing in the previous section? Start negative infinity, right? Goes up to some intercept. I don't know. I'm not going to bother finding it. Goes back straight through and then straight through and then it continues on. So my graph should look something like that. Let's just confirm. As x goes towards infinity, x cubed is going to go towards infinity. So yeah, it should be headed upwards like that. Yeah. So there's my sketch. All right, one down. Now questions 12 through 15, those should also be similar, but we'll save those for the next video.